All right, here we are, my grade 7 class, huh? William, you're smiling. God bless Canada. Okay, excellent. Everyone's good. Tilly's good. Yeah, feel a little better today. Yeah, excellent, excellent. Everyone looks very good. Iman, it was nice meeting your dad yesterday. Give him my best. Hello, Mr. Imam. Iman. Okay. Right. Hopefully, you're showing your parents this before they come in today. Hello, parents of my 7th graders. They're wonderful children, despite the fact that they're teenagers or almost teenagers. So what I want to do today is I want to go over a worksheet that was started with Mr. Nair. Clear? Now, this is the deal. I'll be right back. This is the deal. This is going to make more sense to you now that, matter of fact, what I'll do is I'll get everybody a copy of this. I should have done that already today, but I'll do it tomorrow. Okay. You remember this? Okay. Hi, I'm back. Okay. Do you remember this worksheet where it says worksheet ions? Do you remember this? Does that come up on the thing? Can you see that? Yeah. All right, that's what I'm doing. Okay. Do you remember that worksheet on ions? And on the first page, it gives a periodic table. Can we review the periodic table quickly? Okay. Which side are the metals? Metals on left, on the right are non-metals. Along the periphery of metals and non-metals are called metalloids. Good. We'll go over that a little bit more carefully as we proceed. What I want to do is I want to talk about what ions are. All right? Now, these are the groups of ions. You're going to want to write this down. I'm going to explain to you, so you don't have to memorize anything. I'm going to explain to you what ions are, why ions occur, how do you know what the charge of an ion is, and what to call it, what to call the ion, okay? Yes? Is that okay? All right. So, this is what's most important to understand. Are you ready? Are you ready, Sky? Yeah. Excellent, she's ready. I'm telling you, she looks, yeah. Okay. Ready, Tilly? Everything's cool? Hey, Mary, you ready? Okay. The noble gases. That's it. What's the most stable group of elements on the periodic table? Noble gases. We don't care why they're stable. We just know they're the most stable. Correct? Now, why does an element undergo a chemical reaction? To be what? Starts with an S.
Stable.
To be stable. Excellent. Turn that microphone down. Okay. Elements react so they don't have to react. Let's say that again. That was evil, wasn't it? It was evil? Yeah. So it's going. They react so they don't have to react. They react to become more stable. Yes, Luke? Are you with me? Joseph?
Yes.
Excellent. William? Yes. Yeah. Things react so they don't have to react. Things react to become more stable. So, do you think there's a connection with the fact that elements react to be stable, noble gases don't react because they're stable? So do you think there's some kind of a connection between sodium reacting, sodium's right here, sodium reacting, and a noble gas? Do you think there's a connection? I'm asking you not to know if there's a connection. Do you think, Jamie, that there might be a connection? Yes. Tilly? Yes. Excellent. And there is a connection. Are you ready? If I have two atoms that react, what part of the atoms actually touch?
The electrons.
Yes, but what part of the atoms? Be less specific. Yes.
And their outer shell.
The outside of them, right? These are atoms. They're obviously going to touch on the outer part of the atom, right? Are they going to touch at the nucleus?
No.
No, they're going to touch on the outer shell. Okay? If I have this book, right? You ready? I'm hitting my head. I'm hitting my head with electrons. I'm not hitting my head with nuclei. Right? So I'm hitting my head with the outer shell of electrons. So electrons are really strong, aren't they? Yeah, they are. They have no weight. They're so small, we say they don't even have a mass. But they're there. They're particles. Yes? Yes? Okay. So, chemicals react to be stable. Atoms react with each other and their outer shells react. Correct? Okay. Do you think it's reasonable to say that there's a relationship between the outer shell of the atoms after they react and the outer shell of the nearest noble gas? Maybe? Maybe? I'm not asking you definite answers here, but I say, Scott, do you think maybe? Alyssa? Yeah, and there is. And this is the connection. What's the valence shell of neon? What number? What's the N quantum number, the outer shell of neon? 2, yeah. So isn't 2 the outer shell? Yes? How many electrons does it have in the outer shell? 8, right? Yes? Oh, this is a by the way. Just a by the way. Can I do a by the way? You ready? Valence electrons. Can you see this? Valence electrons. Can you read that? Does that come up? S and P only. When you're talking about the valence electrons, you're talking about the S and P only. In other words, what's the valence electrons of that element? Not the 3D, only the 4s. You see that? What's the valence shell of that atom? Four P and 4s, right? Yes? Not the Ds. These aren't valence electrons, just S and Ps. Okay? Make sense now? A little bit? You making some connections, Jamie? Okay. Sierra? Yeah? You look very wide awake. I wish I looked as wide awake as you.